Okay. So yes, what I was saying, which I thought I had that mapped out. So we'll do solving on Friday, which means we'll review on Tuesday and then take our test on Thursday next week. Wait, nope. That's not true because I'm in service. Sorry. Sorry. We'll review. Okay, so we have one more section after this, which is 3-5. We'll do on Wednesday of next week. We'll review on Friday, and we won't take our logarithms test until 11-9. Okay. Do it. No, next week, Tuesday, y'all are out. And so H day starts on Wednesday. Yes.
Next Thursday, I'm on the TAP field trip to.
That's okay. We don't have this class.
No, that's this Thursday.
Oh, it is this Thursday. Not bad.
This Thursday, we also do not have this class. But thank you for telling me. I hope you have fun.
I was like next week.
Next week, some point. Okay. Hopefully everyone's fast forwarded through our scheduling and our fire alarm. All right. They want all the things. So change of base formula is something you will see in your book that we do not use anymore, but I'm going to show you what it is. We don't use it anymore because our calculators have that log base button. So before, calculators did not have that log base button underneath math. So you had to, if you wanted to plug something in the calculator that had something other than the base 10, you would do log of what you were taking the log of over log of your base. So we do not use that anymore. We use the log base button in our calculator. Unless you have a really old calculator, then you would have to use the change of base formula to plug in something other than base 10. Okay. So when you come across a question on the homework and it says use change of base formula, use the log base button in your calculator. But I still wanted to show y'all what that was. Okay? Yes?
Why does that work?
Why does that work? Okay. So we're looking at, should be able to do, there would be a proof on that. But I would have to see.
We don't do a whole bunch of extra work. I'm just asking.
Yeah. It's not one that naturally just comes on the top of my head, but I'm sure I could create some numbers that would work or that would prove it. Like if I said log base 5 of 5, we know that to be 1, right? So if we had log base 5 over log base 5, I think that is also 1. But again, I'd have to, if you wanted something more generalized, I'd have to come up with that. But which I almost don't like showing this one because I don't want you to get confused when we're expanding and condensing, because we're going to do division there as well. Okay, properties. So we had our exponent properties that if we had x raised to the m times x raised to the n, meaning we had the same base, what did we do to our exponents? Add. So then here, if we're multiplying, we can expand this using addition. Same thing goes for the next one. If we're used to doing x to the m over x to the n, what did we do to our exponents there? Subtract them. So we can expand this one. Whoops. By subtraction. And the last one, if you have an exponent, we're simply just going to move it to the front of the logarithm it applies to, and it'll be multiplied.
I remember that one.
Yeah. So going left to right on these problems, that's expanding. Going right to left, that's condensing. We'll use properties both ways. Okay. So we talked about a couple of these last week, but I wanted to kind of put them as like actual properties. We know that if we do a to what power gets me 1, what do we get? Do what?
0.
0. Okay. So no matter what the base is, log of 1 is 0. Same thing here. A to what power gets me a? 1. So if you have log of base 8 of 8, it's just 1. Log of base 12 of 12 is 1. So if the base and what you're taking the log of is the same number, it's just 1. Okay, the next one's kind of weird because you're in exponential form, but there's a logarithm in it. So it's really confusing when you have the two together, okay? But if I'm changing from exponential to log, I would say log of base A of, we don't know, equals log base A of m. So what does it equal? M. Okay. So we went from exponential form to logarithmic form. Like I said, this one kind of messes with your mind a little bit because you're like, oh wait, there's a logarithm in there. But whenever you see the base of your exponent and the base of your log, then it's just what you're taking log of. Same thing down here. The base of your log, the base of your exponent, we just get r. So if I was going around the world here, I would say a to what gets me a to the r, and it's r. Okay. So if your base and your two bases are the same, you're either going to take the exponent or you're going to take what you're taking the log of. All right. Every single one of these properties, just as I showed you why they are true, you can do around the world, so you don't have to memorize these. They're just shortcuts if you do. Okay. All right. So let's do the first one together. We're going to expand this. So first we're going to expand. And if we understand how to expand, that's going to help us with condensing. And really, condensing is all we need for solving. So the main goal is to make sure we can condense. But we have to learn how to expand first because that's going to help us. All right. So what is the big operation that's happening there? Between x squared and the square root of y. Being multiplied. Now, every single time y'all need to change the radicals into rational exponents. Okay, exponent over index. So I'm going to change that y to the 1/2. All right, so I'm going to show probably way too many steps on the first couple problems, but hopefully it'll help with notes, and then from there you can determine how many steps you want to do in one kind of thing. Okay, so since I'm multiplying it between x squared and square root of y, I can expand that by addition. I changed my square root of y to the 1/2, and now I just have my exponents I'm going to bring to the front. And remember, it's only to the front of the exponent they apply to. I mean, the logarithm, sorry, they apply to. So I do not have anything being multiplied, I have nothing being divided, and I don't have any more exponents, so I'm done. Go ahead and try the next one. Right, so be careful on this one. Main thing here is division, so I'm going to separate by subtraction. Go ahead and change that x to the 1/3. Or 5, I don't know why I just made it 5. Now, we fall victim to this part right here, because we're just so used to a coefficient being in front of a variable. The coefficient is in front of a variable, we're still multiplying, so we still have to expand this out. But we gotta be super careful because this minus sign right here, okay? So when I expand out that 36y to the 4th, I have to make sure to use parentheses. Because another operation is happening inside there. Okay? then I'd have to distribute my negative. That's something that catches a lot of people on these problems, especially when it's that double negative right there. And then I'm going to bring my exponents to the front as well. Okay. Now, can we evaluate log base 6 of 36? What does it equal? 2. Now, I do not have any picky standard form I want y'all to write this in. So you can write it kind of however you see fit. So that's our final answer. No exponents, nothing being multiplied, nothing being divided, and we evaluated the log base 6 of 36. Any questions on that? Okay. Y'all try this. These two, sorry. Not this one. These two. Excuse me. When's the time change supposed to happen? Is that coming up? That November?
Oh, I think so. I don't quote me on that. Do you want me to look?
Yes,
Yeah.
please look.
I want you to please, I need to know, please look.
Well, the clock's already ahead.
Are we really gonna follow these clocks?
Mine's always been right.
Sure.
Naturally, because I'm always right, right?
I feel like, well, cause my mom is one of those people that like, when daylight savings comes around, she always talks about it, so I feel like I would know.
Yeah.
It's November 7th.
Ends at 2 a.m. on Sunday, November 7th.
So it is coming up.
Yes.
Downtown got a lot ahead of themselves.
Daylight savings.
It's not spring forward though, it would go backwards, so that is wrong.
Throw it out. You gotta throw away the whole classroom.
Does that mean we have to leave school an hour later?
Alright,
Because it happens at 2 a.m.
so like I said, you're gonna get to a point where these are gonna move a lot more, I guess. You're gonna be able to do a lot more steps in one, is basically what I'm gonna say. Just don't get too comfortable with that and just start throwing things out there, okay? So if I know I'm multiplying and I know I'm gonna bring my exponents to the front, that's why I almost have to trust that you're actually doing these problems, because you could technically already have that written out, which is the answer, and I have a hard time figuring out who copies the back of the book and who doesn't, so I have to trust that y'all are doing these problems. But yes, we are adding when we separate and then we bring our exponents down.
You did not have to say that.
Me?
Yeah. I mean, like, I'm gonna do them, but like,
Yeah, I'm
you
definitely
did not
doing
have to say that.
I'm trusting y'all.
Okay. I appreciate that,
It's a great
but
idea.
like, you just could have not said that.
But I could have. And I did,
Boom, game.
right?
What is that? I still feel like I still feel like you're losing.
Well, I'm always winning.
Okay.
Yeah, I thought you were Tennessee fan.
You got me. I can't dispute that.
Always winning.
She's a Braves fan. We think she's a Braves fan.
I'm a Braves and a Tennessee fan. I'm always winning. Not really. Okay. So same thing here. If you want to take this one a little bit slower to make sure you get, especially this last part together, I would. Okay. So then I distribute my negative and I deal with my exponents. And then log base 5 of 25 is what?
Please don't do that ever again.
What did I do?
I froze his finger with my pencil. I'm in the middle of it.
And I asked you to stop. And yeah, you just did it.
It's doing
Like a finger prick.
Did you know you have a face print?
this.
Like on the internet, like you have a face print.
Any questions on logarithms?
Walnut's using your face print. What are they used for?
Their main purpose, especially what we're going to use them for, is when you have x in the exponent.
No, I mean like real world application.
Oh, there's
Nothing.
a ton of things actually, but it's like way over
Way over your head.
my head.
Yeah,
You wouldn't understand.
she just likes the
Dead
children.
Yeah, as a math
She,
genius.
again, she has no control over the curriculum. All right, let's go backwards now. We're going to write them as a single logarithm. We're condensing. So this is what we need to know how to do, because we need to be able to condense these to one logarithm when solving. Why? Because then we can go around the world, okay? We can't go around the world when we have multiple logarithms going on.
Why not?
No answer.
No answer. Not gonna answer this question.
Do it.
Not gonna answer this question.
What question was it? I'm sorry.
No, it was
Hey,
you said
Ruth.
why not? And you just didn't say anything. So
You
I
just felt it happen.
I thought it was one of those, you were like, that's such a dumb question.
No such thing as a dumb question.
I feel like I need another cup of coffee.
Just multiply.
The fire drill really throws it off.
The fire drill and the fact that my son is really into, well, at least 2 nights ago, he woke up at 3 until 5, stayed awake, wide-eyed.
I'll be your babysitter. If that's what you're
Hey,
I don't trust
How much you
you.
paying?
Yeah, how much paying?
Children. I would be.
I'm good with kids.
She
I just don't
guarantees you
like
an
them.
A on every test.
I need an app.
He's really good with kids, actually.
And then last night he decided he would do 3 until 4 or so. Just screaming. He has teeth coming in.
That means
Get him a dog toy or something.
Those are so fun. Teeth are
Yeah, something to chew on.
so fun.
I mean, no, yeah, get him a dog toy.
Anyways,
I like the way you think, Dave. Huh?
give him a dog.
Great mind.
Yeah, but
However, our dogs do get really confused when they see half of the toys that he has, and they're like, "That's mine, right?" And I'm like, "That's not
But
yours."
he's chewing on
Give
it.
him
He
some
has to
good
chew on
advice.
it. You chew on sticks. All right, so we are adding. So to condense this, we do what? Multiply. Now, with this particular one, we can take it all the way down to a simplified answer. Because we get 2 times 32, which gives us 64. And 4 to what power gets me 64? 3. So, if it can go all the way, do it. If not, leave it.
Is it just 3 or is there an equation?
Just 3. Okay, the next one, I am subtracting. Now, notice, it's 2 logarithms being subtracted. I'm not asking about what's inside the logarithm. So do not write this as 4x minus 3. 4x over 3. It has to be in between 2 logarithms. So since we are subtracting 2 logarithms, I'd write my answer like that, okay? It is the logarithms, not what's inside the logarithm. Okay, try the other 2. Natural log, same properties. Instead of writing log, you write ln. And yes, I get the question all the time, why is it ln instead of nl? Because it's natural log. And I have kids call it lateral nog.
I like lateral log better.
They're so funny.
Lateral nog.
What humor. Sounds like a Phoenix joke.
No, it's been like years ago. They haven't had logarithms yet.
Phoenix.
In algebra 2.
Oh yeah, when is that? Isn't that nearly the end?
It's like chapter 7.
I don't know what the chapter's on.
Hopefully I do better on this test than I did the logarithm test in algebra 2.
Yeah. That one got y'all.
So did the first one.
Did it get me?
Surprisingly, that one got y'all.
I didn't have to finish chapter, bro.
We're gonna do that in here as well, but you're gonna see like, what was
Well,
I
when you
thinking?
let us retake it, I did well.
Yeah.
So I think he was just
Can't remember.
taking a harder math class.
And learning how to school again. Just like y'all are learning how to do school again now.
Miss Shannon.
Uh-huh.
So with because you said you want us to change radicals to rational.
I want it the other way. I want
Yeah,
it
okay,
turned
so you want
back.
us to change
Uh-huh.
back.
So if it was a rational exponent now, I want it as a radical.
Gotcha.
Just as much as I want the radical turned into a rational exponent.
You okay? What was it?
That was my frustration noise at realizing.
That's not frustration.
It's an interesting frustration.
Frustration noise.
Maybe it was my annoyance noise.
You just make
I
yourself
don't know
sure.
what that really was.
Yeah. So how they get along?
Like randomly throw in the middle of the class.
How did it right?
Like just adding nowhere.
That's just how it is, so. I'll be good with it. Maybe tomorrow when I do this.
Alright, so if I bring up my exponents, I get log of x to the 1/2. Like I said, you probably knock this out in just a few steps, but I'm going to take it all the way for note's sake. And then now that I know that I'm adding in between two logarithms with the same base, I can multiply. And I'm going to go ahead and change the x to the 1/2 to the square root of x times x minus 1 to the 4th. You can leave it that way.
Is there any circumstance under which you would want us to expand?
Just beating.
Okay. Fair enough.
So you'll still take it if we did it like 9.6, right?
Yeah, start getting in the habit of it, because then it is 100% positive, like this is what I'm taking the log of. Because it could be that you take the log of the square root of x, and then you take that answer and then multiply it to x minus 1, so then it just kind of keeps it all together. Alright, bring up my exponents. So I have natural log of x plus 7 cubed over x. Okay.
So this is called what?
Do it.
Like, what's the actual thing called? Is this condensing?
Condensing, yes.
Okay.
I didn't know if this was like, you were asking like, this is section 3.3 or whatever.
So
Okay.
if this is condensing, what's the other one?
Expanding.
Expanding, gotcha. I didn't know if it was like, there's a stupid name for the other one, but this one makes sense.
That does a lot, man.
I just feel bad for the guy that like came up with all this. Like they're like people that like worked their entire life, like came up with this from nothing, and then we're like, let's do it, put it in my calculator.
Or you're like, this is stupid. And they worked their entire life to create something.
They come up with that from nothing. I can barely understand it. You're teaching it to me, and then like they were just like, no, this is how the world works, and they just figured that out. So.
Oh, to be in your mind for a minute. Okay, if you have logarithms that you're condensing and you have more than 2, work left to right. Okay? Work left to right, condense the first 2 together, and then condense it with the third one. So go ahead and try both of these. So basically, solving logarithms is going to include us condensing and then going around the world.
Where are we going to the right?
Left to right. So you'll condense the first 2 together and then condense that. That's the last one. So that way you don't start condensing random things together.
Well, yeah, but wouldn't it make more sense to go right to left?
Yeah.
Because if we condense, or if we expand left to right. So therefore, when you condense the other way,
Always feel you're right. I see what you're saying though, but think about that on one of the problems we've already done, if you did it the other way.
yeah.
Like if you condense,
So there's only 2. Yeah.
that's with the minus though. If it
Yeah.
was expanded out, you would be dividing. You know what I mean?
No.
Like if you had this, like you skipped steps going from here to there, right?
Yes.
So if you had this distributed and you went left to right, you would say divide these 2. And then divide it with that, and then it would be like divide. If you went left or right to left.
School's on. We're gonna go to class.
I don't know, she just won't. Oh, this is an algebra 2 review?
Yep.
Those 310.
We did not do this in algebra.
Yes, we did.
You should have.
Yeah.
I don't think we did.
I don't remember
This
that.
much.
Yep, it's in algebra 2.
Yeah.
All right, so left to right, or let's first bring up our exponents. Okay, so I have log base b of x to the 4th over 6 squared. We'll deal with that here in a second. And then we have log base b of y to the 1/2, which we'll deal with in a second. So if we go ahead and condense the first two together, now that helps us figure out if this square root of y is going to go in our numerator or our denominator. So if I'm multiplying, that's technically over 1. So if I multiply straight across, then it goes in my numerator. So I have log base b of x to the 4th and the square root of y over 36. Which makes sense because the other problems we did when we distributed our negative, this would have been negative right here if it would have been in the denominator. Okay? So that helps to work left to right. Okay? Questions on that one? All right. Down here, we bring up our exponents, and since we're multiplying, I'm giving the answers. Since we're adding, we're going to multiply. Then we have the cubed root of x plus 5. Okay. Any questions on those two problems? All right, let's get started on that homework.